Test 11 review covering Module 11, represent and interpret data. Questions 1 and 2. On average, 9% of the U.S. population gets sick with the flu each year. Based on the accuracy of the most common flu test, the segmented bar graphs show the conditional relative frequencies of test results based on whether a person has the flu. Interpret the data, round to the nearest tenth of a percent if necessary. Question 1, how likely are false positive results and false negative results? So for a false positive result, that means that you do not have the flu, but you tested positive. And so if I look at this bar here, this bar tells me that they do not have the flu. But here it says 7.5% tested positive. So that would be 7.5 would be a false positive. Now the false negative would mean you have the flu, but you tested negative. That would be this column. And I would look at the 40% here because that's testing negative, so that's a false negative. So that would be 40%. The next part of the question is what percentage of the population test positive? So the key word is the population, so both bars combined. So I know that this first bar, the one on the left, this bar here, that represents 9%. So if I take 0.099% of, so testing positive, 60%, 0.6, that will give me an answer of 5.4%. So 5.4% tested positive and has the flu. Now those who tested positive but do not have it, I'm going to have to use this bar. And since the blue was 9%, so if this is 9% of the population, that means this one has to be 91% because the two bars combined have to add up to 100. So I'm going to take 0.91% of testing positive is a 7.5%, so that's 0.075. And when I multiply those together, I get 6.8%. And then I just add my answers, and I get 12.2%. Question 2, find the following values from this data set, then describe the distribution. So the first thing you need to do is we're going to grab our calculator, and we're going to enter that data into our table. So first I'm going to clear mine. So to get to that point, you just hit the stat button, hit edit, and then we're going to type in those numbers. So we got 83, 136, 112, 129, 117, 104, 124, 128, 121, 125, 118, 123, 131, 129, and 125. Once we have entered it all in, we're going to hit stat again, go over to calculate. We're going to choose option 1, which is one variable stats, and hit enter 1. But if you didn't put it in list 1, then you have to add the list 1 here. But as long as you put it in list 1 and you hit enter, it's going to tell you all your information. So now the part that has the first box on there with the X with the bar over it, that means your mean. So I'm going to put it to 1 decimal place, so that would be about 120.3. And then standard deviation. Standard deviation is the bottom one. It has a symbol that looks like this, for the X power. So that's standard deviation. So that one was 12.6. Then we have our five 5-number summary. So if I just scroll down, our minimum is 83. Our max quartile 1 is 117. Our median is 124. Our quartile 3 is 129. And our maximum is 136. Question 3, fill in the table below. So this is a two-way frequency table. So the first two columns, if you add employed and unemployed, that's going to give you the total on the right-hand side. So to find the employed juniors, I would take 20 minus 12, which will give me 8. And I know that 8 plus 15 will give me 23, going down. Now to find going across the middle two boxes, so I have 25 minus 15, that would give me 10. And then I can add straight down, and this gives me 22. Question 4, use the table to the left to answer the following questions. It says find the percent of juniors that are unemployed. So the unemployed juniors are 12. Out of how many juniors? There are 20 juniors, so I'm going to divide this by 20. And when I do that, I get 12 divided by 20 times 100. That will give me 60%. So 60% of the juniors are unemployed. Last question, find the percent of being a senior and being employed compared to all who are employed. So senior and being employed. Senior and being employed is right here. So 15 out of compared to all who are employed. So all who are employed are 23. So I'm going to take 15 divided by 23, multiply by 100, and this gives you roughly 65.2%. Question 5. Determine whether the data are numerical or categorical, and then if it's univariate or bivariate. Letter A, the percentage of adults in an office who drive, take the bus, or carpool to work. So because I have different categories that I'm comparing the adults to, that would be categorical. And I'm only having one variable, how they get to work. So this would be univariate. Letter B, the ages of members at a local gym. So I'm only looking at numbers here, so this is numerical, yeah. And then there's only one variable, and that's their ages, so univariate. And letter C, the number of boys and girls who participate in the 4 most popular after-school activities. So you're comparing the activities, so I have 4 of them, so that would be categorical. And now I have boys and girls, and then I have popular after-school activities. So that is 2 variables, so this would be bivariate. Question 6, use the table to answer the questions. How many gold medals were won in diving? So here's diving, and I go over across to gold medals, and I get 48. How many more silver did swimming win than wrestling? So I look in the silver column. Swimming was 172. Wrestling was 43. So if I subtract them, because I want to find out how many more, so 172 minus 43 gives us 129. Question 7. List the kind of displays under each type of data. So on the test, you're going to get a list of displays, and you just have to say numerical or categorical. So for this one, numerical, I know I can have a stem and leaf plot. I can have scatter plots, because that's just dealing with numbers. I can have a box plot, or a box and whisker. Let me put box and whisker, because that's just all numbers. Histogram. And a line graph. And then under categorical, we would have a bar graph. That includes the segmented bar graph. We got circle graph, and we have two-way tables. Question 8. Find the mean, median, mode, range, and standard deviation of the data set obtained after adding -2 to each value. So I'm going to go back to my calculator. And we're going to enter our data in here. So I go to Stat, Edit. We're going to clear everything and retype them in. So a 31, 20. Actually, let me go back here. It says after adding a -2. So if I take 31 and when I'm adding a -2, I'm really subtracting 2. And then I'm just going to put those new numbers in here. 16 minus 2, 15 minus 2, 23 minus 2, 25 minus 2, 31 minus 2, 12 minus 2, 18 minus 2, 31 minus 2, 28 minus 2. Once I have my data in there, I hit Stat, Calculate, number 1, Enter. So the mean, the average, the 1 decimal place, this would be 20.9. The median, if I scroll all the way down, the median was 21. The mode, the number that appears most often. So if I look at my original numbers, I don't see, actually no, I do see 31 appears 3 times, but remember, I had to subtract 2, so that would be 29. The range, my biggest number minus my smallest number. My biggest number, 31 minus 21, or 31 minus 2 is 29. My smallest number is 12, so if 12 minus 2 gives me 10. So 19 minus 10 gives me 19. And then standard deviation, if I go back up, standard deviation is 6.6. Now going back to a previous problem, question 2, I forgot to describe the distribution here. So when I'm describing the distribution, I want to determine if it's symmetric, is it negatively skewed or positively skewed. One way to check is if you look at your mean and median. The mean is 120, the median is 124. If the median and the mean are roughly the same, pretty much the same, then it would be symmetric. But here they're not the same, so it's not going to be that. You could create a box and whisker plot to help you with this. But for this last one here, this one, since the median is bigger than the mean, that means it's closer to the right-hand side, which if it's closer to the right-hand side, that would be it would be closer to the shorter whisker. And anytime the median is closer to the shorter whisker, we would have that as negatively skewed. So we would say this one is negatively skewed. Now going back to our last one. Describe the distribution in a histogram and box and whisker plot for the following. So for this one, I'm just going to draw a basic histogram and explain a little bit what's happening here. So symmetric means my tallest bar is in the middle, and then I have other bars on each side. They're about the same height. And then for a box and whisker plot, the median is going to be in the center, and then the whiskers are pretty much the same on both sides. So it's even. For negatively skewed on a bar graph, histogram, you're going to have your taller bars on the right-hand side. So let's just say it's going up like this. And then for a box and whisker plots, you'd have a longer whisker here. The median is closer to the shorter end. So that would be what it would look like for negatively skewed. And then for positively skewed, tall bars are on the left-hand side. So maybe we have like this. And then for a box and whisker plots, the shorter end's on the left-hand side. Median's closer to the left-hand side, and the longer whiskers on the right-hand side. So that's what it would look like for a positively skewed. So those are the types of questions you can expect on your Module 11 test.